Hi STAT students, this is Mrs. Settle, and I'm just here going over some information you need to know for your online assignments. And so what we're going to do is we're going to go ahead and go through most of the Chapter 1 content, and then we'll come back and review it when the school year starts. And so we're just going to go over some basic ideas and some stuff that you've probably seen before, and maybe a little bit of new stuff that you haven't seen before, but it shouldn't be too difficult. So we're going to go over section 1.1a, and we're going to talk about individuals. And so you're going to see me, I'm already going to have some stuff typed up so you can pause your video, write down your stuff, and then go ahead and just listen, and then pause and write down stuff, and so on and so forth. I like to highlight stuff because I like to find stuff easily. And so when I'm looking at individuals, they're going to be objects described by a set of data. And objects are usually our nouns, our person, place, things. So individuals, again, people, animals, things, sometimes even places, describing characteristics about places. And then we have a variable. So a variable is any characteristic of an individual. And a variable can take on many different types of values. And there are two types of variables that we're going to be really concerned with, and they're going to be very important second semester when we look at different types of things for different types of variables. And so our two types of variables are categorical variables. So these are variables that places an individual into several groups or categories. Gender is a categorical variable, with categories being male, female. Categorical variable can have a numerical value if it doesn't make sense to average it. So like zip codes, it doesn't make sense to average a zip code. It doesn't make sense to average a phone number. Another categorical variable would be favorite color. So your favorite color would be a categorical variable. Then we have quantitative variables, and that's going to take a numerical value for which it makes sense to find the average. And so then this is when we start talking about mean, median, and mode, first quartile, third quartile, interquartile range, standard deviation, range, all that sort of numerical stuff. With categorical variables, we deal with percentages, and for mathematical purposes, we turn percentages into decimal form, which we call proportions. So a sample problem that you're going to see on your assignment and throughout the year is, here's information from 10 randomly selected U.S. residents from the 2000 census. Now we imported data from the 2000 census into a software program called Fathom. Now we have three main software programs that we use in statistics. Minitab, which is very, very popular among people who truly run statistics in everyday business, marketing, they use statistics everywhere. And that program usually costs about $2,000 to $4,000 and maybe more depending on how expansive you want your program to be. And then we have Fathom software. I'm not sure how much it costs in the real world, but the education version is much easier. That one's only $80 for the educational version. Minitab's educational version is $200. And then there's Jump software. Jump software is nice because it actually has apps for iPads and iPhones. But it's not as user-friendly, and I think that one's about $30 for the educational version. So as you see computer printouts, you'll see different versions depending on which computer software we might use. Most of our tools is pretty much going to be our graphing calculator, which I highly recommend a TI-84, not an 83 because it doesn't give you all the helpful little menus. And then in 89, there's just a lot of other stuff because it is such a powerful tool that it's easy to get bogged down in all the other stuff that it can do. And that's the only thing that's allowed on your AP exam. And it is expected that you're taking the AP exam. Okay, so we imported this data on 10 residents using the 2000 census. And so here we have one resident that lives in Kentucky. Oops, sorry about that. That lives in Kentucky, has two family members, is 61, female, she's married, her income is $21,000 a year, and her phone prefix is 949. And so that's all the different characteristics for that one individual. And so then we have these variables here. We've got the state they live in, the number of family members, age, gender. So these are all variables. So the individuals in our set. So who are we talking about? Well, who we're talking about are these people right here. So the 10 randomly selected U.S. residents from the 2000 census. That is who we're talking about in the entire table. Okay, identify each variable as categorical or quantitative. So we're going to go ahead and start with categorical. So when we look at it, usually if it has words, it's automatically categorical. So state would be a categorical variable. And gender is a categorical variable. And marital status is categorical. And then we look at the numerical ones and see, does it make sense to average? So number of family members, yeah, we average that all the time. Average age, yeah. Average income, yeah. Average phone prefix? Well, phone prefix doesn't really do anything but label an area of where people are. And so we can't have an average place. So this one is actually a categorical data, or a categorical variable. Okay, so now we're going to go to our quantitative. So always numerical. And it should really be everything left behind. Number of family members. And then we have age. And then we have income, total income. And those are all of our categorical variables. And then they ask you, in what units were the quantitative variables measured? So now I'm going back to number of family members. So this is measured as people, not animals included. Age would be measured in years. And total income is measured in dollars per year. Okay, now describe the individual in the first row. So I already highlighted this person. This person is a female, age 61. And so you don't want to just list out things. Because one of the things in stats is you're trying to really communicate with someone. And people don't communicate well when they just list off things. So you need to kind of put together full, complete sentences. A 61-year-old female. That lives in Kentucky. With 2 family members. She is married with an income of $21,000 a year. And has a phone prefix of 949. And then I usually get the question is, what is phone prefix? So phone prefix for the Valley would be like 745 and 746 are usually people who live in Palmer. I know there's a 373 and a 376 are usually people who live in Wasilla. And then there's like an 84, not 841 because that's a cell phone. But there's something else for like Big Lake. And so that's the phone prefix. So our area code is 907 for Alaska, and the first three of our phone number is usually set for a certain area. Okay, so now a couple more vocabulary terms. A distribution of a variable tells us what values a variable takes and how often it takes these values. So I could go back to here and I could look at all the states. So how many or what percentage of the people live in California? What percentage of the people live in Florida? That would be looking at the distribution of the states. Another one would be number of family members. So I'd be looking at kind of a graph, or how many people have 2 family members, how many people have 3 family members, how many people have 4 family members. And usually distributions are shown best using a graph. And so this chapter will also be graphing. How to explore data. So really, when we're exploring data, which is really important to do, and that's what we're going to be doing all year long, is exploring information, we're going to examine each variable by itself. So only look at the state that they live in, or only look at their income. Then we're going to study the relationship among variables. So is there a relationship between how many people live in the house and income? Or is there a relationship between this variable and this variable? We're going to graph distributions to look for patterns. And then we're going to calculate numerical summaries. So we're going to calculate percentages, which are also proportions. We're going to calculate measures of center, mean, median, mode. We're going to calculate measures of spread, range, IQR, standard deviation. We're also going to look and see if something's an outlier. Is it way outside the pattern, or is it close enough to not really be an outlier? Now the last thing that we're going to come to is the 4-step process, which is really important. It's a guideline for free response questions. And this is the part where you really have to show your stuff and you have to keep track of all the different things. So our 4-step process goes like this. We have the state portion. So what is the question you're trying to answer? Being able to rephrase that question in terms helps you when you get to the very end of the problem to state, okay, here's my answer and this is what it means. So if you know the question in context, you can then answer the question in context. So the state and the conclude really pair up together. Because first you start off, what are you trying to answer? It allows us to find the wording for what we're doing, and later on, what we have determined. And then we have the plan portion. So how am I going to go about answering the question? What am I going to do? What statistical techniques am I going to use, and then can I actually use them? Because there are certain times you can use one method, but certain times you have to use another method. So you have to know those distinctions. And then the do part. So out of the 4 steps, the making the graphs, the making the calculations, that's only one little part. Everything else in stats is really understanding and communicating to others what we're doing, why can we do it, and then what does this really mean. Now, our whole purpose in statistics is inference. So we want to draw conclusions that go beyond the data at hand. It is really impossible for me to ask every single person in the United States a question and use that data, which we call a census. We try to make sure we ask everyone that information, and then we just kind of describe, okay, this is what's happening with the entire population. Because we can't ask everyone, or it's really, really expensive to ask everyone, which is why they only do a census every 10 years, is because it's expensive to pay people to go out and find everyone in the United States. Instead, we take samples of data, and we look at the sample and we decide, what can this data tell us about what's really happening in the United States, or what's really happening in the world? And that's called inference. What is this really telling us? And we have 2 types of inference. We have a cause and effect. So can I establish that this actually causes this to happen? And then we have another one of where we generalize to the population. Those are our two types of inferences. Generalizing to the population means that this sample set of data, so these 100 people that I interviewed, they are going to tell me this information about what's really happening in the real world. And so we're going to study the patterns that allow us to say, yes, this really tells me what's truly happening in the United States. Now, the last thing, and probably one of the most important things in statistics, is the idea of association. We can say there is an association between two variables if a specific value of one variable tend to occur uncommon with a specific value of another variable. For example, if smoking in high school increases and then so does drug use in college by those same people, then we can say there's an association or relationship. But it does not mean that there is actually a cause and effect. So in association, we see the same things happening together. We see a relationship there, but does not mean that smoking actually causes this. For example, there is an association between cancer and attending school. Almost all people who have cancer also went to school. So there's a relationship there, but it does not mean that there's a cause and effect. So we always have to really carefully think about things before we spit out our results. And so here's our introduction to statistics. I'm really excited to have you in class, and we'll see you next time.